Hi everyone, and thank you for joining us today. I'm Washizu, and this is Akihiko Odaki. And today we will be talking about releasing SR-IOV on virtual machines. Uh, sorry. Okay. んなんかずれてますよね。Okay, sorry. First, as an introduction, I will explain the multi-tenant environment. A multi-tenant environment refers to a model where the same system or service is shared and uh, multiple unrelated tenants. When building this environment, there are two main requirements. First, it must be cost-effective. This is a primary motivation for adopting a multi-tenant cloud. In a multi-tenant cloud environment, resources and utilization is maximized by eliminating the need for an infrastructure dedicated to each tenant. Second, it must be a secure environment. And since multiple tenants share the same server in the multi-tenant environment, each tenant should be able to view and configure only their own resources, requiring an independent environment. In such a multi-tenant virtualization environment, SR-IOV as shown in this page is very useful. Single root I/O virtualization, SR-IOV, is a technology that allows a single PCIe device to provide multiple network functions, including physical function PFs and virtual functions VFs. The PF allows the host to configure the VF through the PF. The VF can be exclusively assigned to VM or containers. This technology is beneficial for two main requirements of a multi-tenant environment. By offloading packet switching through the PF, it reduces the virtualization overhead, making it cost-effective. Moreover, it ensures security by assigning network function exclusively. However, in some situations experience issues when attempting the offload. Next slide. The specific situation refers to container workload. SR-IOV cannot offload packet switching between container within VM. Containers in the VM require their own virtual network, but the VM cannot offload this virtual network to the hardware. SR-IOV can control the VF through the PF, as shown in the left figure. In container workload on the physical machine, admins can control the VF network by accessing PF. However, However, in the container workload VM, admins within the VM cannot access the PF and therefore cannot control the VF. And from here, we will present our proposal for this issue, this problem. Okay. To provide an interface that offloads packet switching within VM, we propose emulating SR-IOV with VMM3. By emulating SR-IOV, we can provide an SR-IOV interface, allowing SR-IOV to be used within a VM. In this context, we refer to the PF inside the VM as the virtual PFs, and the VF created through the virtual PF as the virtual VFs. This interface will enable the VM to control hardware through the virtual PF in the future. There are three advantages of SR-IOV emulation. First, SR-IOV can be treated the same way as in the bare metal system. This allows existing door configuration software such as the SR-IOV-CNI plugin to be used as is. Second, since it's not necessary to assign physical PF to each VM, it is scalable. Third, it is Third, it is secure because users are prevented from controlling the entire NIC. Although it is called emulation, it is possible to reduce overhead by using a vDPA and vDPA vDPA device as a backend. vDPA is a technology that emulates the control plane while offloading only the data plane. By combining this with the SR-IOV emulation, it is possible to reduce the overhead of container networks. Additionally, since SR-IOV emulation has a pluggable backend, it can be used for other use cases by replacing the backend with a different device. For example, by using a top device as the backend. The SR-IOV capable .INET driver in guest OS can be used for testing. While SR-IOV emulation provides SR-IOV interface, network functions related to SR-IOV are expressed as device groups in VirtIO spec 1.3, version 1.3. Device groups allow the owner device to control its member devices. Several features have already been proposed using device groups, and the provision of interface through SR-IOV emulation also help use these features on VMs. We are considering extending the VirtIO specification based on the device groups to achieve packet switching. Currently, the functions to offer packet switching within the VM doesn't exist, and this remains a future work. Although still in the conceptual stage, we are considering processing the TC configuration within the VM via QEMU and offloading it using a bridge that including virtual PF and virtual PF and virtual VF and in the host OBS OpenVSH. From here, I will explain how we combine SR-IOV emulation with vDPA to reduce overhead and the extent to which performance improved. We verified performance with the following setup and confirmed the performance improvement of about two. Oh, sorry. We from here and we explain. Oh, sorry. Okay, I verified performance with the following and set up and confirm the performance improvement of about 2 times. This LIVM Sienna plugin used was modified slightly to apply to a virtual CSFS. We verified the performance using SR-IOV-VF as the backend into 2 environments with NetPerf as the measurement tool. The baseline environment without offloading in VM used PCI device assignment, while the with offloading environment used a combination of vDPA and SR-IOV emulation, reducing overhead with SR-IOV. The metrics were throughput and latency, and the measurement section was between container in the VM and external machine. And first, about throughput, the average value of UDP bulk transfer was measured as the result. Both transmission and reception performance improved by 2 times. And latency and the 99 percentile value of UDP round-trip transfer was measured as the result. The latency was reduced by 100 microseconds, showing performance improvement.
It's behaving very odd. Yeah, このままでいい。Okay. Now, that's I remember the development progress of SR emulation, particularly in QEMU. First, this is the history of SR emulation. So first, because the first RFC patch to introduce SR device in 2014, that was for Intel network device, and in 2019 we got better spec for SR support. However, the development of SR emulation in QEMU kind of bit stalled for a while, and work resumed in 2022 when we got the first SR device NVMe upstreamed. And in 2023, we got the network device IZB upstreamed. And now we are working on Butter.NET to add SR support. From now on, I'm more focused on Butter.NET. Butter.NET is, unlike IZB or NVMe, it is proprietary, so it has much more flexible configuration. For example, it can have varying number of virtual functions, and it can also have different backends for different virtual functions. So this provides a lot of flexibility that make proprietary device useful, but it also means we need to somehow configure such various properties. Instead of inventing a new way, I decided to learn from the conventional PCM multifunction. SR is somewhat a variant of multifunction, so it will make more sense to follow the previous, current mechanism for multifunction. And for multifunction, it is very simple. So we have QEMU devices for each we have a QEMU device for each function and add multifunction property to the function 0 and specify address property. So I also decided to have similar interface for SR-IOV. So it also has others properties. Instead of having multifunction property, I added SR-IOV-PF property that pairs physical function and virtual functions. So this allows any kind of virtual function configuration and also physical function configuration. So it looks nice in theory, but it also means the flexibility of configuration is directly exposed to user. So we somehow need to handle this flexibility in the implementation, and it's a bit more complicated. So I'll first explain the challenge with its hot bragging nature. In SR-IOV, virtual functions are enabled at runtime, so it's like hot bragging. But it also has some difference from normal hot bragging. That is, the whole process is controlled by the guest. So in the SR way, the guest configures the resource allocation in the device, and the guest initiates enablement of virtual functions. So it is fully controlled by the guest. So we need to fulfill the expectation of guests. So for example, we need to reserve function numbers and underlying resources such as network backend. And we cannot fail because in physical SR-IOV device, these resources are already included in devices and cannot fail. But that is not the case for hot bragging. And today, SR-IOV emulation literally relies on the hot bragging mechanism, and that's cause mismatch with the model SR-IOV is providing. SR-IOV expects all resources are reserved, but with hot bragging, those resources are not reserved, so that can result in unexpected runtime error. And the hot bragging mechanism is initiated by the physical function automatically. So physical function needs to configure a virtual function and needs to define its own command line interface for this virtual function configuration. If you try to use the conventional command line interface, and this command line immediately plugs virtual functions instead of hot bragging, so it is incompatible with the current methodology. So now I'm suggesting to avoid hot bragging for SR-IOV. I have patches for this change. In this change, I decided just to realize the virtual function when the pair of the physical function gets realized. This makes things a lot simpler. It reserves function numbers and resources automatically, and virtual functions will be able to be added with normal device command line. However, just realizing this virtual function will make them visible to the guest, while the guest expects they are invisible until until the guest enables virtual functions. So we implemented the disable state for virtual functions. For this purpose, I list the code to power down PCI devices, so it minimizes the additional complexity. And finally, we enable them when the guest requests, and that's perfectly conforms to the model SR-IOV specification provides. The second problem is the validation of SR-IOV device configuration. unlike conventional multifunction, SR-IOV actually imposes as multiple restrictions. So we need to validate those restrictions. Well, usually these restrictions do not matter if you have uniform virtual functions configuration and some same address assignment. You can pass those restrictions easily. But still, we have code to check those restrictions are enforced well with the user provided configuration. I also limited the SR-IOV device composition to multi-tenant PCI as precaution, but this can be expanded to other virtual PCI devices or even other computer-defined PCI devices if wanted. Okay, and then I'll summarize this presentation. As background, we talked about virtual network offloading with SR-IOV. By emulating SR-IOV, we can provide configurability to the guest to run run containers on virtual network. There are some proposals to explore the emulated SR-IOV capability for virtual, and it can even support packet switching if we add necessary interface. And of course, SR-IOV emulation is already there, so we can use it for testing now. And now our benchmark showed big win with offloaded packet switching. That is kind of simulated environment, so the host configures as packet switching, but still we can show some numbers, and it showed double throughput and latency reduced to third. And we are working on adding SR-IOV emulation for multi-tenant, and I hope this will run in the next version. Yes, so that's all. Any question? Comments?
So I think it's all good. We could maybe, do you think we could maybe make it a bit easier, for users with all these tricky restrictions? Like, like the stride, for example, because the users don't know what the stride is that you put in the capability. So like you're checking them, but against the restrictions that you didn't really provide. Maybe we could come up with. Do you think we could come up with like an easier interface?
I don't have particular plan, but yeah, the address would be the most. The address property is the most tricky one. We need to enforce it has constant stride, and well, perhaps it may be possible to use the existing automatic address assignment mechanism. So this continuous sequential assignment would work for this. So work for most cases. So it will be not that difficult to have some mechanism to automatically assign just to have constant stride 0, 1, 2, 3, and so on. Yeah, but I don't have implementation for that now.
So correct me if I'm wrong. The way I understand this is you use the VFs not for yet another level of virtualization where you pass these in. You use the VFs basically to get multiple network interfaces, right? So multiple data streams across through the host. Have you considered just implementing VLAN tags and making those be part of your data stream?
Well, the current SR-IOV emulation just passed through the network backend, so it does not perform any kind of operation, just pass through. But well, in the future, yeah, certainly we can implement some kind of mechanism into battery to handle VLAN or other IP.
What I'm saying is, as an alternative to SR-IOV, so the reason you expose SR-IOV and you want to use SR-IOV is so you get multiple network interfaces in the guest that run on different networks, right? And you do that by basically creating multiple new queues
Yeah.
and multiple new devices behind those queues. But you could use the same queues, just use native networking mechanisms like VLANs to steer your actual traffic, which also gives you different interfaces in the guest. So what's the benefit of doing this?
So the virtual functions can be assigned to different virtual machine in the so
Okay, so you're basically, this is for a Kata-like use case where you have another layer of virtualization in your guest.
yeah. So yeah, it's more like nested situation.
Cool. Then it does make sense. Perfect. Thank you.
Also to emulate how the actual hardware will work, because the vendors now implementing virtual net hardware devices with SR-IOV. So it's kind of emulation of how the actual hardware will work.
I'm super happy with that work. It's great, by the way. Thank you. What I was just wondering about the use case, right? The particular use case for just only Linux in your VM, you can solve differently, probably cheaper and easier and more flexible. This is really, really useful when you do nested VMs.
Yes, no other questions. Thank you.
So we have the patches for SR refactoring, and also have RSC patches for SR battery or SR emulation. So please check out if you are interested. Yeah, thank you for.